Hey guys, welcome to the session by Intellipaat. So Python is a versatile language which is used for multiple purposes such as web development, machine learning and deep learning. And the best way to get expertise in Python is to work on hands-on projects. So today we have come up with this capstone project on Python so that you get a complete understanding of the data science lifecycle. So before we start off with the class, do subscribe to our channel so that you get a notification of our next video. So let's go through the agenda. We'll start off by implementing some data manipulation operations with the pandas library, and then we'll use matplotlib to visualize the underlying data. After that, we'll implement some machine learning algorithms using scikit-learn. And finally, there'll be a quiz to recap what we've learned in today's session. So do put down your answers in the chat box so that you know if you've answered correctly. And also you can put down all of your queries in the comment section. We'd love to help you out. So without much delay, let's start off with the class.
Consider yourself to be data scientist at a prestigious telecom company, and the name of that company is Neo, and they are facing a major problem, and that basically is their customers are churning out to other competitors. Now you as a data scientist at that particular company have to make sure to stop this churning out, and also have to find out the reasons why customers are churning out to other companies. Right, so this is the problem statement, and what you're basically going to do is a bit of data manipulation, data visualization operations, and then you'll go ahead and build the ML algorithms on top of this data set. So you'll start off with the linear regression algorithm, and then you'll build the logistic regression, decision tree, and random forest algorithms. All right, and we'll be working with this customer churn data set. So this is our data set which comprises of all of these columns. So we've got customer ID, gender, senior citizen, partner, dependents, and so on. Right, so so this is our first task, data manipulation, and to do this, let's go ahead and actually import all of our libraries. So I'll just type in import pandas as pd, and then I'll also load the numpy library. So I'll type in import numpy as np. I'd also need the matplotlib library, so I'll type in from matplotlib import pyplot as plt. So these are all of my required libraries. I'll just wait till these libraries are loaded. Right, this is done. Now I'll also go ahead and load up my customer churn data frame, and I'll store it into an object and name that object to be equal to customer churn. I'll just use pd.read_csv. And inside this, I will give in the name of the data frame, which is customer churn.csv. Right, so I have successfully loaded the file and I've stored it into a new object, and also I've named that new object to be equal to customer churn. Now I'll go ahead and have a glance at the head of this. So customer churn dot head, and this is the data set on which we'll be implementing all of the operations. So this is just the unique customer ID. This column gender tells us about the gender of the customer, whether the customer is male or female. The senior citizen column tells us whether the customer is a senior citizen or not. So if it's 0, then the customer is not a senior citizen. If it's 1, then the customer is a senior citizen. And then this tells us if the customer has a partner or not. This tells us if the customer has dependents or not. This is the tenure of the customer in months, right? So 1 month, 34 months, 2 months, and so on. This tells us if the customer has phone service or not. Does the customer have multiple lines? And this is the type of internet service used, and then whether the customer has online security, whether he has device protection, tech support, streaming TV, streaming movies, and so on. And then this column is for contract. So this just tells you the contract type of the customer. So the contract type of the customer could either be month to month, 1 year, or 2 year, and there's a type of billing, whether it is paperless or not. After this, we have the type of payment method. So the type of payment method could be these: electronic check, mail check, bank transfer, and so on. And then these are the monthly charges and total charges incurred by the customer. Right. So now let's start off with our data manipulation tasks. So this is our very simple task. We just have to extract some individual columns from the entire data frame. We'll have to extract the 5th column and store it in customer 5. So let me do that. I'll type in the name of the data frame first, which is customer churn, and I would use .ilog. I would need all of the rows, and I would need the fifth column since the indexing starts from 0. So 0, 1, 2, 3, and 4, right? So this would be my fifth column over here. And I will store this in, let's say C underscore 5. And I'll have a glance at the head of this, C underscore 5 dot head. Right, so we have successfully extracted the fifth column from this entire data frame, and this is the head of it. Similarly, we'd have to extract the 15th column and store it in customer 15, right? So if it's the 15th column, then the index number would be 14, because again, the indexing starts from 0, right? I'll store this in C underscore 15, and I'll also make this to be C underscore 15. I'll click on run, right? So this is the streaming movies column, and I get the same thing over here. This is column number 15, and I've extracted only this particular column from the entire data frame, right? This was basic extraction of columns from the entire data frame. After that, we'd have to do data extraction on the basis of a condition. We'll have to extract all the male senior citizens whose payment method is electronic check. Right. So there are three conditions over here. The first condition is the gender of the customer needs to be male. Second condition is senior citizen, the value of senior citizen needs to be equal to 1. And the third condition is the payment method needs to be equal to electronic check. So I'll give in all of these three conditions over here. I'll start off by giving the first condition, customer churn. I'll type in gender, and the gender needs to be equal to male, right? I'll cut this and paste this inside this. Of this, I'll use the AND operator and then given the second condition. So the second condition would go something like this, customer churn. After this, we'd have to set the senior citizen value. Right, so senior citizen, this needs to be equal to 1. And then I'll go ahead and give in the third condition. So over here, the third condition, this is for the payment method column. So the payment method needs to be equal to electronic check. All right. So I have all of my three conditions over here. I'll just paste a cell below. Now, what I'll do is I will copy all of these three conditions and I will paste them inside this, and I will store it into a new object and name that object to be C random, right? Now I will print the head of this, C random dot head. So we see that this, so if you have a glance at this gender column, then you'll notice that all of the values are male. Similarly, if you have a glance at the senior citizen column, then all of these values are 1. Similarly, I'll go to the payment method column, then you'll notice that all of these values are electronic check. So I've given three conditions over here, and all of these conditions have been satisfied. So next up, we'd have to extract all of those customers whose tenure is greater than 70 or their monthly charges is greater than $100. Okay, again, we'll do the same thing. Customer churn, tenure needs to be greater than 70. I'll put this up inside this. Now, what you need to notice over here is we are using the OR operator. So it's either the first condition or the second condition, right? So if one of these conditions is true, then we'll get that particular record. So again, customer churn, and this time it's the monthly charges. So the monthly charges have to be greater than 100. These are the two conditions. So either the tenure of the customer needs to be greater than 70 months, or the monthly charges of the customer needs to be greater than $100. Again, I'll insert a cell below, and all I'll do is cut this and paste it inside this. Right. And I will store this in, again, C random Now let me again print the head of this, c random dot head. Right, now I'll head on to the tenure column. Now you see that none of the tenure or none of the values of the tenure over here is greater than 70. But if I go to the monthly charges column, then you'll notice that the monthly charges are greater than 100. So it's either or. So one of these conditions has to be true. And in this case, we see that the second condition is true over here, right? So if either of the condition is true, then we'll get that entire record. After this, we'd have to extract all those customers whose contract is of 2 years, payment method is mail check, and value of churn is yes. Right. I'll again copy this, paste this over here. Let me delete this from this. Right, so we have these conditions over here. So we'll have to extract those customers where contract is of 2 years, payment method is mail check, and churn is equal to yes. So let me put in all of these conditions over here. First is contract, and this needs to be equal to 2 years. So let me just check, how is it? Contract is of 2 year, right? 2 space year. After that, it's the second condition, and over here the payment method needs to be equal to mailed check. Again, I'll put in the double equal to operator, and I'll give in the value, and the value is equal to mail check, and then I'll give in the final condition over here. So customer churn, and this time the churn needs to be equal to yes, right? So I've given all of these three conditions and I've separated them using the AND operator. Again, I will store this in C underscore random. Let me print this out, C underscore random. So we see that there are just three records, or there are just three customers who satisfy all of these three conditions. So let me have a look at the contract of this, right? So contract is of 2 years for all of these three customers. Next is the payment method, and again payment method is mail check and churn. All of these values are yes, right? So out of all of those 7,000 rows, only there are 3 rows which satisfy these three conditions. Next, this is a question on random sampling. So we just have to extract 333 random records from the entire data frame. And to do this, we'll be using the sample function. So I'll type in customer churn and I'll use the sample method over here. And inside this, what I'll do is I'll give the value of the number of records which I want to sample. So I want 333 records. I'll store this in C underscore 333. Let me print out the head of it. Right, so now what I'll do is, so whenever I run this, every time I'll get a different sample of 333 records. I'll run this again, right? So if you have a glance over here, so all of these values would be changing, the customer IDs would be changing, the indexes would be changing, right? So keep a glance or have a glance at these row IDs indexes over here, right? So again, if you have a glance at this, the row IDs are changing. So this is random sampling. I'm randomly sampling 333 records from this entire data frame over here. And I'm doing that with the help of the sample method. Right, and then this is the final operation when it comes to data manipulation. So I'd have to get the count of different levels from the churn column. So if I want to get the count of the different levels present in a categorical column, I have the value counts method. So first I'll give in the name of the data frame, which is customer churn. After that, I'll give in the name of the column, which is churn. And then I'll just type in value counts, right? So this is it. So let me just wait till I get the result, right? So we see that no, so the number of customers will not be churning out is 5,174. and the number of customers who will be churning out is 1869. So you can do the same thing for other categorical columns as well. So let's say if I want to get the count values or the number of counts of different levels for, let's say, the contract column, I'll just change the name of the column over here. So I'll put it to be equal to contract, right? So there are 3,875 customers whose contract type is of month to month. There are 1,695 customers whose contract is of 2 years, and there are 1,473 customers whose contract is of 1 year. Right, so these were some basic data manipulation operations. After that, we'll head on to data visualization. All right. So here we'd have to create a simple bar plot for the internet service column. And yeah, we'd have to set the x-axis label to categories of internet service, y-axis label to count of categories, the title of the plot, distribution of internet service, and the color of the bars need to be equal to orange. Right. So I'll just type in plt dot bar over here. Now I'll insert another cell over here. Now what I'll actually do is, so this basically takes in two parameters first. So the first parameter is the names of all of the bars, and the second parameter is the values for those bars, right? So the names of the bars would be coming from the internet service column. So internet service, and I actually want the value counts of this. Value counts, and from this I don't want the values, I just need the keys. And again, I'd have to convert them into a list. So I'll use list over here. Now I'll click on run. Let's see what do we get, right? So these are the three levels present in the internet service column. So from this internet service column, what I've done is I've used the value counts method. So this value counts method has two things, keys and values. Now I don't want the values as such, I just want the keys, and I'll take these keys and I'll convert these keys into a list, right? So this is the list of the names present in this internet service column. Now I'll cut this and paste it over here, and this would be my first parameter, and my second parameter would be all of the values. And if I want all of the values, I'll just remove the method keys from there, right? So this over here would give me all of the values present with respect to this internet service column, right? So fiber optic, or in other words, the number of customers whose internet service is fiber optic is 3,096. Number of customers whose internet service is DSL is 2,421. And number of customers who don't avail the internet service are 1,526. Right? Now again, I'll cut this and I'll paste it over here. Now let me print this out. So this is my basic bar plot over here, right? So this is my bar plot. On the x-axis, I have the names representing these bars over here, right? So this bar is for all of the customers whose internet service is fiber optic. This is for those customers whose internet service is DSL, and this is for those customers who are not availing the internet service. And these are their counts over here, present on the y-axis. Now, I had to do some other things over here. I had to change the color of the bars. So the color of the bars was supposed to be set to orange. And for this, I have the color parameter, and I'll just set it to be equal to orange. I'll run this again, right? So we have successfully changed the color of these bars over here. Now I'd have to set the x-axis label and the y-axis label. So I'll just type in plt.xlabel, and the x label needs to be equal to categories of internet service. Let me type that down. Categories of internet service. After that, I would need to put in the label for the y-axis. So this would be plt.ylabel, and I'll just put it to be equal to count. And then finally, I'd have to give in the title. So plt.title, and I'll set the title over here. And the title needs to be equal to distribution of internet service. Let me type that out. distribution of internet service. I'll click on run, right? So this is our final bar plot, which gives us the distribution of internet service, and the x-axis label is categories of internet service, and the y-axis label is count, right? So this is how we can create a simple bar plot, and all of this. So these are the basic steps behind before you go ahead and build all of your machine learning algorithms. So the pre-processing, the data pre-processing part is always the main part of your data science life cycle. So this is where you properly comprehend your data set. This is where you understand the structure of the data set. You understand the correlation between all of the columns, the correlation between the dependent variable and the independent variable. So by manipulating the data set and visualizing the structure of the data set, this is where you understand all of the patterns in the data set and you get insights from the data set. Right, so next up we have to build a histogram for the tenure column. So again, it'll be a similar operation, plt.hist, and I'd have to build a histogram for the tenure column. So it'll be customer churn tenure, and I'd have to set the number of bins to be equal to 30, and I'd have to set the color to be equal to green. So I'll just type in color equals green over here. So this is our histogram, and this gives us the distribution of the tenure of the customers. So yeah, so if you look at it closely, so this is basically the count over here, right? So there are around 800 odd customers whose tenure is not even 1 month. So they are churning out before they even complete 1 month. And again, there's a huge peak over here. So there are around more than 600 customers whose tenure is 70 months or more than 70 months. And then rest is pretty much the same, right? So the average customer, yeah, so this is the normal range of the customer. So it's between 200 to 400. And the average tenure of the customer, you can say, would be somewhere between 20 months to 50 months or 60 months, right? And this is where you have the peak. So you have the peak at the starting and you have the peak at the ending. Again, let's go ahead and add the title. So it'll be just plt dot title over here. And the title of the plot needs to be equal to distribution of tenure. I'll do that. All right, so I have created this plot, and this is the title of the plot, which is distribution of tenure. So we've made a bar plot, we've made a histogram. Now, you guys also need to understand the difference between a bar plot and a histogram. So a bar plot is normally used for all of the categorical columns. So whenever you want to understand the distribution of categorical columns, that is when you'll go with a bar plot. And when you want to understand the distribution of a continuous numerical column, that is when you'll go with a histogram. Right, so next up, we'd have to create a scatter plot between monthly charges and tenure. So tenure is on x-axis and the monthly charges is on y-axis. So plt dot scatter, x-axis would be tenure, so customer churn, tenure, and then I'll set in the column for the y-axis. This will be customer churn, and this will be equal to monthly charges. Let me just run this, right? So this is what we get over here. Now let me also set in the labels for this. So plt dot x label, and this would be equal to tenure. Let me type in tenure over here. Similarly, I'll also set the y label over here. So this will be plt dot y label, and this would be equal to monthly charges. Right, so now we also get the corresponding x and y axis labels. After this, I'll also go ahead and set the title. So it'll be plt dot title, and this would be monthly charges versus tenure. Monthly charges versus tenure, right? So this is our final scatter plot where we have the x-axis and y-axis labels, and this is the title, which is monthly charges versus tenure, right? And finally, we'd have to also build a box plot between the tenure column and the contract column. So tenure needs to be on the y-axis and contract needs to be on the x-axis. For this, I'll just type in customer churn dot box plot, and so now I'll set in this to be equal to customer churn contract, and after this I have the column to be equal to customer churn, and this needs to be equal to tenure. Let's see what is the error over here. Columns not found. So let me actually remove this from over here and let's see what happens. Alright, so now we get the result. So we had actually given the name of the data frame initially itself, so it was customer churn dot box plot. And now all we have to do is assign the contract onto the x-axis. So now when I said by equals to contract, what is happening is I'll have one box plot each for the different levels of the contract column. So I have one box plot for the month to month level. I have another box plot for the 1 year level and another box plot for the 2 year level. And over here, the y-axis, this is being determined by the tenure column, right? So this over here, 0 to 70, this is the tenure of the customer. And what we understand from this box plot over here is, so if the contract of the customer is of 2 years, then most probably the median tenure of the customer is very high. So if the contract of the customer is of 2 years, then his tenure or median tenure would be around 65 months. Similarly, if the contract of the customer is 1 year, then the median tenure of the customer would be around 45 months. And then if the contract of the customer is month to month, then the median tenure of the customer would be around 15 odd months. Right, so these were all of the examples of visualization. Now it's finally time to head on to machine learning. Right, so this was your data pre-processing part, where you had understood the structure of the data. You had learned how to extract individual columns, and after that you learned how to visualize the data and get some interesting insights from the structure of the data. So we'll start off with our first machine learning algorithm, which would be linear regression over here. And linear regression, as you already know, so over here the dependent variable would be a numerical column, and you're basically trying to understand how does one variable change with respect to another variable. And over here we'd have to build a simple linear model where our dependent variable is monthly charges and the independent variable is equal to tenure, right? So, or in other words, we are basically trying to understand how does monthly charges vary with respect to tenure. So monthly charges, dependent variable, tenure is the independent variable. And these are all of the subsets when it comes to this linear model. So we'll start off by dividing the data set into 70-30 split, and then we'll build the model on the train set, pick the values on the test set. After that, we'd have to find out the root mean square error, and yep, we'd have to print out that root mean square error. So let me go ahead and import the linear regression model from sklearn. So I'll type in from sklearn import linear model. After this, I'll type in from sklearn dot linear model import I need linear regression, right? So these are my two basic libraries. So I needed linear model, I needed linear regression. Now I would also require the train test split. So I'll type in from sklearn dot model selection import train test split, right? So this train test split method would help me to divide my dataset into training and testing sets. So now it's time to divide my data into training and testing sets. So before that, I'd have to get my target and the features, or in other words, I'll have to separate my dependent variable and the independent variable. So monthly charges is the dependent variable, So what I'll do is y equals, and I'll extract only the monthly charges column, and I will store it in a new variable and name that variable to be equal to y. Similarly, I'll only extract the tenure column, right? So I'm extracting the monthly charges column and I'm storing it into a new object, naming that object to be equal to y. Similarly, I'm extracting only the tenure column and I'm storing that column into x. Rent columns, customer churn. What seems to be the problem over here? Monthly charges. Let me put it to be capital C over here. Right. Now let me print out the head of these two. Y dot head and x dot head. Right. So these are the values from monthly charges column and these are the values from the tenure column. Now let me go ahead and divide these two into training and testing sets. So I'll use in train test split. I'll pass in x as the first parameter. So all of the features would be which are stored in x go as the first parameter. After that, I'd have to give in the target labels, and the target labels are which are basically my monthly charges, which are stored in y. And then finally, I'd have to give in the test size. So let me check what was the test size. So the test size was supposed to be 0.70. And then I'll also set a random state. So if I want to use these values again, I can just set the random state to be equal to the same value which I'm giving over here. This is smallest over here, right? So this test size 0.70 basically means that 30% of the records would go into the testing set. Oh, this has to be 0.30. Sorry for that. Yeah. So 30% of the records would go into the test set, and 70%, the rest 70% of the records would go into the training set. Now I'll be getting 4 results over here, and those 4 results are xtrain, xtrain, ytrain, xtest, and ytest. These are actually the labels which we conventionally use. I'll explain what these are exactly. Xtrain, ytrain, and then we have so this would actually be xtest first, xtrain, xtest, ytrain, and ytest. So over here, xtrain represents all of the all of those values of your features which are present in the training set. Xtest represents all of the features which are present in the test set. Ytrain represents all of the dependent values which are present in the train set, and ytest represents all of the dependent values which are present in the test set. And whenever we are building a model, we'll build that model on top of the train set, right? So we'll build the model on top of xtrain and ytrain. Let me also show you the shape of all of these. So xtrain dot shape. Let me do the same for the rest. Xtrain dot shape. I'll make this to be ytrain. I'll make this to be xtest. And I'll make this to be ytest. Right. So xtrain, ytrain. So the training set has these many records, and the testing set has these many records over here, right? So these are all of the features which are present in the training set, and these are all of the features which are present in the. Sorry, these are all the features of your dependent variables, and these are all of the features of the independent variables, and these are all of the target values when it comes to the test set, and these are all of the target values when it comes to the when it comes to your dependent variables. Right. So now that we have xtrain, ytrain, xtest, and ytest, let's go ahead and build the model on top of the training data. Now I will go ahead and create an. So normally your training data would be bigger because so let's say your splits are either 70-30, 65-30, or 80-20. Because the more data you give for training, that is better. But then again, you can't give out your entire data for the training set, right? So the purpose of training your model is to make sure that your model learns the underlying patterns of that data. And once the learning is done, you'd have to also test how well the learning is done, right? And to test, you'd also need a sample space for that test set. So consider this simple case. So let's say you're giving an exam, and but for that exam, let's say if you got 100 exercises. So your syllabus comprises of all of the 100 exercises, and you'd have to learn all of those 100 exercises. But when it comes to your test, it will have only 10 exercises from all of those 100 exercises, right? So the training needs to be done, but then again, the test space, it needs to be completely new, which is not learned by the model, during the training phase, right? That is why the training set has to be completely different and the test set has to be completely different. And the division of training and testing set is done to make sure that overfitting doesn't happen. And when overfitting happens, the problem is this model will perform well on this particular data set, but when a new data set comes in, it'll miserably fail, right? So this is the reason why we divide the data into training and testing set. Right, so now let me go ahead and create an instance of the linear regression model, and I'll name that to be regressor. So I've created an instance of linear regression over here, and I'll go ahead and fit the model on top of the training set. So it'll be xtrain and ytrain. Right, so I fit the model on top of the training set. Now it's time to predict the values. So it'll be regressor dot predict, and I'll be predicting the values on top of the x test. And I will store this in, let's say, ypred. Now I've fit the model on top of the training set, and I've also predicted the values on top of the test set. Now I'd have to know how well the prediction has been done. And for this, when it comes to linear regression, we have something known as the root mean square error. So the lower the value of root mean square error, the better your model. And again, we have an inbuilt method to calculate the root mean square error. So I just have to import sklearn.metrics, and from sklearn.metrics I'd be importing mean square error. Now after this, so mean squared error, what we actually want is root mean squared error. So I would need the np dot square root, and let me use the mean squared error, and this takes in two parameters. First parameter comprised of the actual values which are present in ytest, and second parameter are the predicted values which are present in ypred. So I will cut this, and let me ease this to be in this over here, right? So we get a root mean squared error value of 29.39. Right, so now let's say if you build some other model with some other independent variables. Now we'll go ahead and build the model, and we'll also predict the values. Now after predicting the values, we'll also have to calculate the root mean square error. So this root mean square error is actually relative. So let's say if there is some other model, let's say model 2, and if the root mean square error of that model 2 is, let's say, 39, then this model would be better than the second model. Similarly, if there's, let's say, model 3 whose root mean square error is 19, then that model 3 would be better than this model which you built over here. So here we are predicting the monthly charges values. That is exactly right. So let me actually show you that. So let's see, I'll put in y prith, and let's say I'll have a glance at the first 5 values, right? So these are the monthly charges predicted. Let me also show you y test, then 5, right? So these are the actual values and these are the predicted values over here. Right. So this is not exactly dependent on the churn of the customer. So what we are doing is we are building an entire data science lifecycle process. So over here we are trying to understand the relationship between the tenure of the customer and the monthly charges of the customer, right? So over here, what we're basically trying to understand is, let's say if the tenure of the customer is at around 10 months, what would be his monthly charges? Again, if the tenure of the customer is 30 months, what would be his monthly charges? Similarly, if the tenure of the customer is 70 months, then what would be his monthly charges? So this is what we are trying to understand over here, right? So this time we'd have to build a logistic regression model where dependent variable is churn and independent variables are tenure and monthly charges. Again, I do the same thing. Let me actually copy these two. So this is what we did over here, Aditya, right? So this is where we went ahead and predicted the values, didn't we? Right? So I have divided my data set into training and testing set. And over here, I am fitting the model only on the train set, right? So training is happening on the training set, or the model is learning from the train set. And we are predicting the values on the test set. So this model, this linear regression model, has not yet seen all of the records present in the test set. It has only learned from the values which are present in the training set. So we'll go ahead and build the linear regression model now. Customer churn. Let me also put in y. I'll do the same thing. So in the logistic regression model, our independent variable is monthly charges. Let me put monthly charges over here, and the logistic regression, sorry, the dependent variable is churn. So I have extracted or I have got my features and my target over here. So features are basically my monthly charges and my target is present in the churn column. And I'd want to understand if the customer would churn or not on the basis of the monthly charges of the customer, right? So I've done this, and the rest of the process would be the same over here. I'll go ahead and divide this data frame into train and test, right? So this is 65-35 ratio this time. So I'll set it to be 35. So this time 35% of the records would be present in the test set, and the rest 65% of the records would be present in the train set. And I'm storing all of those into xtrain, xtest, ytrain, and ytest. Right. After this, I'd have to import the logistic regression model. So from sklearn dot linear model, I'd have to import the logistic regression model, and I'd have to create an instance of this. So I'll name this to be equal to log model. All right, so I have created an instance of this, and I'll go ahead and fit the model on top of the training set. Right, the entire process when it comes to implementing this is pretty much the same, right? So Python makes it extremely easy. The sklearn library makes it extremely easy. All you have to do is take in the data, find out your independent variables and your dependent variable, and then go ahead and divide those target and features into training and testing set, build the model on top of the train set, and then break the values on top of the test set. And then you will find out the metrics. So for classification, it's confusion metrics and your normal accuracy score. And for linear regression, it could be either root mean square error, mean square error, or moving averages error. So log model dot fit, and I will fit this model on top of the training set again. So xtrain and ytrain, right? So I have fit the model. Yes, we can also have multiple independent variables, Sharadata. So again, so if we have a single independent variable, then that's that's a simple model. So when it comes to simple linear regression, we have a single independent variable. When it comes to multiple linear regression, you'll have multiple independent variables. Right. So this basically means that we are trying to understand how does our dependent variable change with respect to multiple independent variables over there. And so again, consider this equation. So linear regression equation is based on this. Let me actually open Notepad over here, right? So y equals, let's say, x1 plus x2 plus x3 plus x4. So what happens in a simple linear regression is you just have one independent variable, which would be x1. What happens in multiple linear regression is you have multiple independent variables, which are x2, x3, x4, and so on. Right? And you're trying to understand how does y vary with respect to all of these independent variables. That's pretty much it. Right, so let's proceed with this. We have built the model on top of the training set. Now let's go ahead and predict the values on top of the test set. So it'll be log model dot predict. So here we change the value of x, and no, we are not changing the value of x. We have multiple x values over here, right? So this becomes mx1 plus m2x2 plus m3x3 plus m4x4 and so on. We have multiple independent variables, and you are trying to understand how does y vary with those multiple independent variables. So log model dot predict, and I want to predict my values on top of the test set, and I'll store this in again y pred, right? So we have predicted the values now, right? So when it comes to a classification model, we can use the confusion metrics, right? So let me import the confusion metrics. So from sklearn.metrics, I will import the confusion metrics, also the accuracy score. Now let me find out both of this. I'll pass in the actual values and the predicted values. Actual values are present in y-test and predicted values are present in y-pred. Similarly, accuracy score, I'll do the same thing. Y-test and y-pred. Right, so this is our confusion matrix and this is the accuracy, right? So to get the accuracy, what you'll basically do is you'll divide the left diagonal with all of the values. So left diagonal represents all of your correctly predicted classifications. So this comprises of all of your true positives, right? So this part over here, this is all of your true positives and this is all of your true negatives, right? So when you divide this with the entire sample space, that is when you will get the accuracy. So let me do that. So that'll be 1815 divided by 1815 plus 651. And I get the same accuracy, which is 73.60, right? So I get an accuracy of 73% for the model which I've built. Now I'd have to build a multiple logistic regression model where the dependent variable is the same and the independent variables are tenure and monthly charges. So now we have two independent variables. So I'll make the changes here itself, right? So Charada, the question which you're asking, what if we had multiple independent variables, right? So over here, we have two independent variables. So this time the independent variables are monthly charges and tenure. And I'm trying to understand whether the customer would churn or not on the basis of these two columns, which are monthly charges and tenure, right? So X now would comprise of these features and Y is the same. And the ratio is 80-20. So I'll change the test size to be equal to 20 over here. I'll go ahead and fit the model. It's the same. Again, I'll predict the values is the same, right? So I build the model. I predicted the values. The only difference which I made over here is I have two independent variables this time instead of a single independent variable. Right. Predicting the values. After that, I'll import confusion metrics and accuracy score. Right. Now, over here, again, I'm calculating the confusion metrics and this time I get an accuracy of 77.50. Right. So this time it'll be 935 plus 157 divided by 935 plus 157 plus 106 plus 211, right? So we get an accuracy of 77.50. So this left diagonal are all of the values which have been correctly classified, and this right diagonal represents all of those values which have been misclassified. So this was logistic regression, and then we've got two more machine learning algorithms left, which are decision tree and random forest. So let's build these two. Right, so for decision tree, dependent variable is the same, which is churn, and independent variable is tenure. Right, so let me manually do this. X is customer churn, and the independent variable is tenure. Let me also extract the dependent variable. So the dependent variable would be churn. You have to make sure that you put in the spellings correct, and also you have to take care of the small caps and the capital letters over here. Right, now I will go ahead and also import the decision tree classifier. So from sklearn dot tree, I'll be importing the decision tree classifier. Now I'll go ahead and divide this data frame into train and test. So it'll be the same process. Let me copy this. Let me paste it over here. So the split is 80-20, which is what we are doing over here, right? So this is our feature, this is our target labels, and we have divided the dataset into training and testing set. Now let me go ahead and create an instance of this decision tree classifier. I'll name this instance to be, let's say, my tree, right? And I'll go ahead and fit the model on top of the training set. So my tree.fit, this takes in two parameters, which are xtrain and ytrain. I fit the model. Now it's time to predict the values. My tree.predict, and I'll be predicting on top of the X test. Now I'll import the metrics, right? So let me calculate the confusion metrics and also the accuracy score. Confusion metrics. So I'll actually have to store this in a object first. Again, I'll be storing this into ypred. Let me run the cell again. And this again takes in two parameters. First parameter is all of the actual values which are present in ytest, and all of the predicted values which are present in ypred. So this is our confusion metrics now. Let me calculate the accuracy, which would be 965 plus 87 divided by 965 plus 87 plus 281 plus 76. Right, so for this decision tree model, we get an accuracy of 74%. Right, so the process is entirely the same, guys, right? What we are doing is, again, at the risk of being redundant, so what we are basically doing is finding out our features and target variable. After that, we are dividing the features and target into training and testing split, and then we'll go ahead and build the model on top of the train data, and then we'll predict the values on top of the test data. Once the prediction is done, we'll calculate the accuracy to find out how well our model has learned. right? So in the entire data science life cycle, our most important part is the data processing part, right? So because to the model building the so it depends on your problem statement, Aditya, right? So let's say if your dependence on your it depends on your problem statement and what exactly you're trying to find out. So let's say if your dependent variable is a continuous, if it's a continuous variable, if it's a continuous numerical, then you'll go with linear regression. And if you want, if you have multiple categories, right? So if you have multiple categories, then you'll go with either decision tree or random forest. So when it comes to logistic regression, it is a binary classifier. So let's say if you have just two labels in your dependent variable, like this case over here, right? So this is where you'll go with logistic regression. But then again, if you have multiple categories or if it's a multi-classification problem, then you'll most probably go with decision tree and random forest. And again, when you compare decision tree and random forest, random forest is always better than decision tree because random forest is an ensemble model. So again, through your course, you would have learned that a random forest is nothing but an ensemble of decision trees. And the accuracy or the prediction given by a random forest is better than a decision tree. So that you can actually take for granted, right? So whatever accuracy a decision tree gives, the accuracy given by a random forest is better. So just to verify that, let me actually go ahead and build a random forest model on this same data over here, right? So we'll take the same X and Y values. No, so again, problem statement was different, Aditya. So linear regression we use to understand how does monthly charges vary with tenure. But the other algorithms which we've built, that was to understand how does churn vary with other factors, right? So over there, monthly charges was a numerical column, but churn is a categorical column. So we can compare logistic regression and decision tree, right? So let's say if we compare logistic regression and decision tree, right? So logistic regression gives us an accuracy of 77%. Yes, yes, right. So logistic regression till now, yes, has given us the best accuracy, right? Right. So now finally, we'll also go ahead and build an ensemble model, which is random forest. So let's actually compare the accuracy given by this decision tree and the random forest. So from sklearn dot ensemble, I'll import the random forest classifier and I'll create an instance of this. Maybe I'll name this as RF and I'll just create an instance. Right. And I'll go ahead and with the model on top of X train and Y train. X train and Y train I fit the model. Now it's finally time to predict the value. So rf dot predict, and I am predicting the values on top of the X test. Let me build the confusion metrics over here. Right, now let me check the accuracy. So I'll just type in accuracy score and I'll pass in Y test and Y pred. Y test, Y pred. So we get an accuracy of 74.66 and it's 74.66, right? So there's not much of a difference when you compare decision tree and random forest over here, right? So we've got the same values, right? But normally in general, if you're building a random forest model, so you'll either get a better accuracy or you'll get the same accuracy, right? So this is your normal entire data science life cycle. So you'll start off with the data pre-processing part, data exploration part, where you will understand the structure of the data set. You'll visualize the data set and understand whatever is happening underneath it. Right after that, once you understand and comprehend your data properly, that is when you'll go ahead and build your model. Again, when it comes to building your model, you will sort of follow the same procedure. You'll find out your independent variables and the dependent variable. Then you'll go ahead and divide those two into your training and testing set. You'll build the model on top of the training set, and then you'll break the values on top of the test set. And finally, you'll calculate the accuracy. Right? So here, this is pretty much it for today's session, right? So this is your entire end-to-end project on the customer churn dataset, which comprise of data manipulation, data visualization, and implementing all of the machine learning algorithms.
So this brings us to the end of the session. If you have any queries, do comment below. We'll reach out immediately. Also do subscribe to our channel so that you don't miss out on any of the upcoming videos.